Let's finish the chapter.
What?
Finish the chapter.
Throw a bunch of toes.
Finish 4? I didn't even finish 3. I don't even.
Wait, did you adopt a cat now?
No.
No, we've had plenty of cats and
I don't
dogs.
know what happened to the cat.
We had a dog.
I would have adopted it.
No.
You're weird.
Winning it. No.
We need a lot of cats in our town.
We have a lot of cats in our town. There was one house they tried to burn down, and when they burnt it down, and as they bring these cats flying out of the house, they said somebody counted like over 150 cats.
Oh my gosh. Oh,
So
yeah,
you
I
have
need
cat
hunters.
ladies.
So
There's cat ladies in
The cat infestation in that town.
Where was that? No, was it in New York? Some cat lady died and she had like 237 cats in her house. And they were like, half of them were dead because there were so many of them. And
I
it's
see
just
TV shows
disgusting.
about that too, where they're like hoarders, so then they like
Yeah.
move the thing, and then there's like a skeleton laying there.
Yeah, there was a
That's-
hoarder too.
that's
They had a
crazy.
fire in the cities and they couldn't like get in because there was so much stuff.
there is a nasty. So I
Ah,
don't know why. Did you hear that thing about sports? Did you hear about that hockey player from Farmington?
No.
no.
Yeah, was it today? What, Thursday? Tuesday night?
He made his own goal
Yeah, I heard
and then
about
ran off the ice.
No, the team, he was a goalie for Farmington. Farmington was ahead 2-1 with like 2 minutes left in the game. Somebody must have really ticked him off from his own team. Because the puck came behind the net, he picked the puck up and threw it in his own net, scored on his own self, walked over to his bench and flipped off his whole team and walked up the ice.
Wow.
Gabe's cousin goes to Farmington,
So I was like,
but he
whoa.
plays basketball. That's
Like-
really.
I think they ended up losing 3-2 because they had no other goalie. But
That's
Did he get kicked off the team?
I don't know, they didn't say that. So the principal was investigating.
Yeah.
probably didn't
There's
know.
probably a
Well,
likely
if Mr.
cause
A
if
was
he
the
went to
principal, he'd be
that
like,
far.
A
you
lot of
gotta
stuff
go back
going weird.
to
Like Herman's
practice.
situation now.
What happened to Herman?
Herman, they're changing the lock. I guess I found that stuff yesterday. They're changing the locks in the school because they fired the superintendent.
They
Really?
did? What?
Yeah, they got rid of their superintendent over there, so they changed the lock so you can't get back in the building.
When? Is he like a creeper?
I don't know.
Who's
That's
their
weird.
superintendent?
So
Yeah, and Oscar
God,
Pistorius, the guy with the double amputation legs, just shot his girlfriend and killed her.
In
He's the
Herman?
Olympic runner.
he did that.
Yeah, he got charged with murder for.
Oh, I didn't
Wait,
know
what
that, so-
happened?
He's the only Olympic. He was a double amputee. They cut off both his legs, and he was that runner in the Olympics last year.
He killed his girlfriend?
He shot his girlfriend and killed her.
He claimed it was an intruder.
Yeah,
whatever.
he said it was an intruder, but he shot her like 5 times.
In the head.
Okay, let's finish up chapter 2 or get close to that. And I'm not here tomorrow, so you have 5 of you here to work. And then we don't have school till Tuesday, so. We
You
talked
guys school
about
on Tuesday?
till
Oh,
Tuesday, and then we'll see what
As I
next week
said.
brings. No, got by with this storm, no snow, didn't miss school today.
Yeah, we know.
Like next chance probably is Thursday next week, so. I heard Wednesday.
Supposed to be something come over the weekend.
It looks like
Of
it passed
course
us,
they'll
that's Wednesday, I looked at the forecast, right now they say Wednesday, heavy snow Wednesday night.
Well, I don't want it anymore. I don't any more morning practices.
Yeah, we have games. I don't want to switch a game for practice.
Alright.
I don't want to. I don't want to
Charlie.
have postpone game
Doesn't
either.
matter.
So,
What?
Doesn't matter if you guys have a game or not.
don't
Well, I
know what
mean,
you're talking
Yeah,
about.
'cause
Probably
then they have
matters to
practice.
them.
Well,
Okay. That's it, going. Compliments of,
you guys.
compliments of the.
All right, keep going.
Kelly, you guys would die.
Why would?
You have-
What?
All right, Karski, but that's out of line.
Matthew, they have 7 games and 3 practices. How many games in a row can you have before you're dead?
Quite a bit.
I think we'll be fine.
No, we have Friday, Monday, Tuesday, Wednesday practice, Thursday, Friday, and Monday.
A few games. So,
Not very. Oh, we don't know.
Okay.
It's fine.
compliments, let's head back to math now. Compliments of, Ben, we talked about this yesterday. Compliments is the opposite. So like rolling a die and getting a 4, the opposite is a 1, 2, 3, 5, or 6. Selecting a letter in the alphabet and getting a vowel, the opposite is getting a consonant. Selecting a month and getting a month that begins with J is the opposite months. Selecting a day or week and getting a weekday is getting Saturday and Sunday. And rain, opposite of rain would be
Snow.
Sun.
sun, snow, there's a lot of options there. So compliments as you go here. If the probability that a person lives in an industrialized country in the world is 1/5, find the probability that a person does not live in an industrialized country.
Forfeit.
Forfeits.
Forfeit.
Hard math.
Hard math, we're doing hard stuff here. Okay, sample spaces and probability. There are 3 basics. We talked about this already. We talked about classical. Let's go into empirical now. Empirical probability, a relative frequency approximation of probability. We rise on actual experience, observation to determine the likelihood of outcomes. I talked about this yesterday. I said on an experiment we use like a frequency distribution, a sample from a group. We use this to do our They use a different definition here. They say probability is frequency of desired classes, sum of all frequencies, good outcomes over total outcomes. Still use it, but looking at the options on the chart. In a sample of 50 people, 21 had type O blood, 22 had type A blood, 5 had type B blood, and 2 had type AB blood. Set up a frequency distribution and find the probability a person has type O blood. Okay, we got type O blood. How many people had type O? 21 out of
50.
50. So the probability that a person has type O blood is 21 out of 50. Not real hard there, right? That's it.
That's it.
So that's not too hard. We want to make sure when you do some of these problems, they might throw you as an error. Check this out. You got 43, 44, 45, 50 people. Make sure that the total people add up to how many they say there is.
What if they don't? Like, would they do
Then
that?
it'd be hard to do. I mean, it'd be a hard way to say can't do because we don't know what the other ones are. So if there's something that doesn't add up correctly, you might have to say not enough information. A person has type A or type B blood.
27.
You got 22 with type A, 5 with type B, so 27 out of 50. This probability should be pretty easy, first one. Person has neither type A nor type B, O blood. So they have type B or type AB, right? So the type B is 5 and type AB is 2, so 7 out of 50.
Take a test on these blood.
Yeah. Cruising
Is
through
type
it.
O like the regular? No,
It's
type
like
O
type-
is O negative.
A and
AB
B is
negative.
their.
I have
That's 40
AB
out of
negative.
50 or.
Okay.
Well,
You should
don't
get
get
blood.
I do. I always
Oh,
get
yeah.
blood.
Okay, a person does not have type AB blood.
That's gonna be 48 out of 50. That's gonna be
Person has type AB blood is 2.
24 or 25.
Okay, 2 out of 50 is the ones that have type B blood, AB blood. So it does not have type AB blood would be the opposite, which would be
48 out of 50.
48 out of
or
50.
24 or 25.
If you simplify it down, it would be 24 out of 25. And you should simplify them down. I didn't do them on the other ones. You should as you go.
The other ones are coming.
I didn't think they could.
They're all odds.
Okay, so that's empirical. We're gonna do a lot of problems like this. And the last one is subjective probability. Subjective probability uses the probability of a valid guess or educated guess or estimate, employing opinions and inexact information, or by using knowledge of the relative circumstances. For example, weather forecasting, predicting outcomes of sporting events. You know, there's no set reason it's going to happen any time this way. It's per chance. So we don't do a lot of examples with subjective. Now, these are probably the two definitions that's probably the hardest. Independent events and mutually exclusive events. They look like the very same definition. We're going to start with mutually exclusive. We're going to talk to independent later. And we have to know if events are mutually exclusive because it changes the probability as we go through. And you can see the formula down here. Two events are mutually exclusive events, disjoint, if they cannot occur at the same time. They have no common outcomes in common. So they are mutually exclusive. They cannot happen at the same time.
So it'd be like
Like
blood type.
an example.
Example. Blood type. Flipping a coin. You can't flip a coin and say you get heads and tails at the same time. Okay? They're mutually exclusive. So the odds would not overlap.
So it's something.
Non-mutually exclusive is flipping a coin, say rolling a dice, and getting a 2 or getting an even number.
Oh.
Because 2 is an even number, so they are not mutually exclusive. Those two events overlap a little bit. Okay, that makes sense a little bit?
So is not mutually exclusive independent?
No, it's a different definition for independent. Okay? So the events are mutually, we're going to do some examples. And this, like I say, first part, 4-1, you guys look at 4-1 today, that's pretty easy. This is nice. Now we're going to start getting all these different formulas. It's going to get a little more harder to determine where everything goes. So I'm hoping that if we don't do enough examples, we'll do more in the book too. Probability, if they are mutually exclusive, we just take the probability of one and add it to the probability of. And if they are not mutually exclusive, then we have to subtract the probability of A and B, and I'll explain why in a second. Okay? In a single trial, okay, the key word in this section is or. It is inclusive or, which means either one or the other. This is what happened. The A and B. let's do an example. If I'm rolling a dice, getting a 2 or getting a even number, okay? Here's here's the probability of getting a 2. Here's the probability of an even number I'm going to put in here. And so if I think about a dice, let's say for example, I would have 2 would go into here, and then I would have 4 and 6, and then I have 1, 3, and 5 on the outside, okay? Because this is the 2 would go inside here, because 2 would overlap both areas, right? Everybody follow me there? So that's kind of how the Venn diagram works. Now what happens here is when we take the probability of A, probability of A is this whole thing here, right? So if I said, what's the probability of getting a 2 on a dice? 1 in 6, okay? So if I think about this, I got 1 in 6. What's the probability of getting an even number? 3 out of 6. 3 out of 6. Now what's the problem with that is this. Probability of 2 is 2 out of 6, because, or 1 out of 6 because of the 2, right? Probability of even number is 3 out of 6 because of the 2, 4, and 6. We counted that 2 twice. Didn't we? So therefore, what we need to do on this is subtract the overlap. How many overlaps are there? 1 out of 6. So the answer to this would be a 2 or even number would be 3 out of 6. Yeah, 3 out of 6. 3 out of 1/2. Okay? Because what happens when you have that overlap, it counts it twice on the formula. So when we don't have an overlap, what we can do is just say probability of A happening, probability of B happening, and this goes. There's no overlap. Okay? Now let's start. Determine which events are mutually exclusive and which are not when a single die is rolled. Getting an odd number and getting an even number.
Mutually exclusive.
Mutually exclusive. Can't happen at the same time. You can't get an even number, you can't get an odd number at the same time.
What if there's a 0 on the die?
Getting a 3 or getting an odd number.
Not mutually exclusive.
Not mutually exclusive. Okay? Write them down and we'll check all the answers at the end here. C.
Can I go get my packet on the line?
Sure. All right, write down your answer. Getting an odd number and getting a number less than 4. Write it down. D, get a number greater than 4 and get a number less than 4. So if we go back, so if we go back here, getting a 3 or getting a number, Mr. Stiegel.
Not mutually exclusive.
Not mutually exclusive, yeah, because the 3 and the odd number overlap, right? Okay. We gotta pick another one through 4. Kelsey. Get an odd number and get a number less than 4.
Not,
Not why?
because you can get a 3.
You can get a 3. Get an odd number.
1.
4 or 1. Stephanie.
Mutually exclusive.
Which is good. Greater than 4 or less than 4. Can't do it. They both all overlap, so there's the difference between these two. Okay, Paul, at a political rally, there are 20 Republicans, 13 Democrats, 6 independents. If a person is selected at random, find the probability that he or she is a Democrat or a Republican. First thing I want you to do is decide if they're mutually exclusive. Can you be write down your answer. Can you be a Democrat or a Republican? Or can you be both, or can you be one or the other? Okay. This one is mutually exclusive. Can't be one or the other. So what we do here is very easily, if they are mutually exclusive, we take the probability of A plus the probability of B, and there is no subtracting because they are mutually exclusive. So the probability of A is the probability of being a Democrat looks like it'd be 13 out of 39. So we got 13 out of 39 plus the probability of being a Republican is 20 out of 39, which makes it out to be 33 out of 39. Take a 3 out of both, and we get 11 out of 13. These are mutually exclusive, so we just do that. That's it. Make sense? Okay, next one. In a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are female. If a staff person is selected, find the probability that the subject is a nurse or a male. Not mutually exclusive. No, I always had I have a hard time. Hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. So I'm going to make a little chart here. Nurses, physicians, and I have to do this myself because I have male and female. Close enough. Okay, now you have 8 nurses and 7 of the nurses are female, so I'm going to go 7 female, 1 male, right? And physicians, there's 5 physicians, 3 are female, 2 male, right? Now I got my chart. Now the question comes in here is, find the probability that the subject is a nurse or a male. Now I'm going to say nurse is A and male is B. That make sense? So what we're going to do is, if it's not mutually exclusive, we're going to say probability of A plus the probability of B minus the probability of A and B. So the probability of A, what's the probability of being a nurse? There's how many people in total? 13? So probability of being a nurse is what? 8 out of 13. Okay, 8 out of 13. Plus probability of being a male. 3 out of 13. Minus the probability of being a male nurse. 1 out of 13. So if I work that out, I get 11 out of 13 minus 1 is 10 out of 13, looks like. Sound good? Makes sense. Bring it around. I don't know if the chart helps. For me, it helps a lot. Because especially some of these problems get more difficult, I have to write it out to see where everything goes. I can see it better as I make a chart out.
We're gonna get 3 though.
So, hang on for a second. Let's go to your book before we move on to the next part here. Once you do number page 195, number 17, we'll talk about it. 195, number 17. Did I post the homework for chapter 4? I will do that. Okay, number 17. If the slow is selected at random, the show is a quiz show or is shown on Channel 8. Who is it, Doctor? Whitney.
My answer?
Mm-hmm.
I got 14 out of 31.
Sound good?
Yep.
14 out of 31? Okay. Option B, the show is a drama or a comedy.
23 out of 31.
23? Good. C, the show is shown on Channel 10 or is it a drama? Okay. Mark. 11, show is Channel 10 or a drama. You may look different.
I got 19.
19. Shows Channel 10 would be 11, right? And the drama would be 10. So that's 21 out of 31, right? And the overlap would be 2. Okay, so then you subtract the 2, so you get 21 minus 2 is 19 out of 31. Okay, let's try another one. 23.
There's 52 cards in the deck. Right?
Correct.
Okay.
Which one was it? 33?
23. Okay. 23. King or a queen or a jack. 3 out of 13. I agree. 12 out of 52, right? Okay. A club or a heart or a spade. What else? 3 out of 4. 3 out of 4. 3/4 of the deck, right? A king or a queen or a diamond.
19 out of 52.
19 out of 52. If you have any question on any of these, you're not getting them done. Okay, next one. An ace or a diamond or a heart. 7 out of 13. Let me go over this. 7 out of 13. 7 out of 13. And the last one, a 9 or a 10 or a spade or a club.
15 or
15 out of 26. These aren't too bad. Those aren't too bad. Okay. Now we're going to get into multiplication rule. That's that section now. Keep moving along here. If I get up into it. There we go. Two events, now this is kind of different, independent. Two events, A and B, are independent events if the fact that A occurs does not affect the probability of B occurring. So you got two events happening. Okay, for a good example, okay, it says here examples of independent events. Rolling a die and getting a 6, and then rolling a second die and getting a 3. What happens on the first die does not affect to happen on the second die, right? Those are independent events. The second one, and this is the key word here, drawing a card from a deck of cards and getting a queen, replacing it, and drawing a second card and getting a queen.
That was good.
And it does not affect the events because drawing a, now, they are independent because if I drew a card from the deck of cards, drew a queen, put it back into the deck, what's the chance of drawing another queen? Same. Now, if I drew the card and put it off to the side, and then what's the chance of drawing a queen the second time is less, 3 out of 51, right? So that odds change. Now it's a dependent event because the odds change as you go through. Now you'll notice on here the formulas, and then we'll talk about these formulas a little bit again. Probability of A and B. Now you notice the last section we did a lot of ors. A, or is it a king or a queen or a spade or a club, right? Now in this chapter, this section, we're going to do a lot of ands. Probability of A and B happening. If they're independent events, we just multiply them together. Multiply A, probability A times probability B. If they're independent events, kind of the same thing, we multiply together, but it's the probability of A times the probability of B, and what this means here is the probability of B given that A happened. Probability of B given that A happened.
So we like wouldn't replace the card.
Yeah. So what's the probability of, you said 3 out of 51. What's the probability of drawing a queen in the second card if we didn't replace it? 3 out of 51.
So you just times like 4 out of 52 times 3 out of 51.
Yes. And that's kind of where the probability gets in there, okay? And it's, my pen is really not working here. The 5% guideline for cover sing calculation. If a sample size is no more than 5% of the size of the population, treat the selections as being independent, even if the selections are made without replacement. So they are technically dependent. So I don't get into this too much. I will look at it more as if the odds change, but this is some books talk about the independent 5% rule. Applying the multiplication rule. It's got a probability of multiplication, probability of A and B. A and B independent, we do this formula. I really like to repeat myself in the slides. Again, if they're independent, if they're not independent, we're going to do this. Okay? It's kind of repeating itself. Okay, let's do this one. Coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on the die. Are they independent? One does not affect the other. These are independent events. So the find probability of getting a head on the coin. What's the probability of getting a head on the coin?
1 out of 2.
So we take 1 out of 2 times probability of getting a 4 on the die. 1 out of 6. So the probability of this happening is going to be 1 out of 12. Correct? Okay, next one. A coin is flipped in the dice rolled. Already did. Okay, next one. A Harris poll found that 46% of Americans say they suffer great stress at least once a week. You guys, great stress any day, right?
Yeah.
If 3 people are selected at random, find the probability that all 3 will say that they are suffering great stress at least once a week. Now, here's that rule, 5% rule. Okay, you say independent. Now, if you say, if I took the first person, I picked the first person, would the odds of the second person go smaller then? I pick the second because the population gets smaller. Let's say, for example, it's 100 people in the group, and they say 3 out of this 100 is going to be, or 46 out of 100 are going to be stressed, right? What's the odds? It said, what's the odds of picking 3 people? All 3 will be saying they're stressed, right? Pick the first person, they're stressed. Now, how many people are left? There's
99.
99 people, 45 are stressed, right? But what they're saying on this 5% rule is, if this percentage they're working with is over 5%, we treat it as independent. So we don't worry about going smaller. So if we're thinking about that, well, how do we get 36% now? I'm going back to 6, 4.
46
How do you, 46 out of 100 or as a decimal? So the probability the first person would be stressful is 0.46 times. The probability the second person is going to be stressed out is the same. We're not going to go lower because it's over 5%. So 0.46 times the probability the third person is going to be stressed, 0.46. Now we multiply those together and we get our answer, and that's the answer. Since it's over 5%, we don't worry about the decrease in the odds changing. If it was only 4%, then we would have to worry about it a little bit. 0.2116. So
Oh,
about
wait, just kidding.
just kidding.
I typed it in wrong.
0.09736.
0.97336. So how about 9? Oh, just 3. 9.7336%. That sound about right now? Not too bad. Okay. At the University of Western Pennsylvania, there were 5 burglaries reported in 2003, 16 in 2004, 32 in 2005. If a researcher wishes to select the random 2 burglaries to further investigate, find the probability that both have occurred in 2004. So the first 2 distinct cases. The first case is selected and not replaced. So how many cases we have? 53. They gave you. $53. So what is the probability both occur in 2004? What's the chance the first one occurred in 2004? 16 out of 53. What's the chance the second one occurred in 2004? 15 out of 52. Because it says right here the case is not replaced. So we would go 15 out of 52. Multiply it out, set the 5 down, get your answer. Question on that? Any answer?
60 over 689.
60 over 689? Usually write it as fraction or decimal. You know, if you start with decimals, leave it as decimal. If you start with fractions, try to leave it as fraction. Okay. Conditional probability is the probability that a second event occurs given that the first event has occurred. Now, there's a couple of different ways of looking at it. A conditional probability could be written as probability of A and B over the probability of A. Probability A and B means what happens both occur. The probability that Sam's Park is a no parking zone and gets a parking ticket is 0.06. Sam parks in a no parking zone and gets a ticket is 6%. And the probability that Sam cannot find a legal parking space and has to park in a no parking zone is 0.2%. On Tuesday, Sam arrives at school and has to park in a no parking zone. Find the probability that he'll get a ticket. So what we're looking for is this. We're looking for probability he'll get a ticket given that he parked in a no parking zone. Okay, that makes sense? Now, if you look at the previous screen or previous slide, we have this all, probability of A, I'm gonna use A and symbol, and B, divided by the probability of A. Right? So now let's think about what's the probability of A. Now, I always have to lay up here. A is going to be probability he parks in a no parking zone. That's probability of A. Probability of B gets a ticket. Here's B. That makes sense? And then the probability of Sam cannot find a legal parking spot and it has to park in a no parking zone. So here is A again. The probability of A. So if I was writing my stuff out here, what I have here is cannot find probability that he's going to park in a no parking zone. Probability A is 0.20, correct? So that's the bottom. So probability he's going to park in a no parking zone is 0.20. The top probability he parks in a no parking zone and gets a ticket is
So that's probability A and B.
that's probability of A and B. The first
So they already gave it both.
they gave us A and B, right? Yep. So if we work this out, .06 divided by 0.2, 2 decimals over, 6 divided by 20, 3/10, 0.3. So probability he's going to get a parking ticket is about 30%. That makes sense. Using that formula, these are the ones that get to be, like I said, again, they're labeled by A and B. Last one through. Recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. Results of the survey are shown. Male, female, total. I didn't answer the question. Next slide. Okay. Find the probability that the representative answered yes, given that the respondent was a female. So A and B. A is going to be given that they were a female, or female. B is answered yes. So we're looking for the probability of B, they answered yes, given that they were a female. Now, if I wrote this out, I would have it over. This is a probability of A and B divided by probability of A. Correct? Now, if I think about that, probability of A and B. Probability it's a female and voted yes. 8 out of what? 100. 8 out of 100. So 8 out of 100 there. Probability of A. Probability it's a female. Probability of female. 40 out of 100?
No, that's
50.
yeses. It's 50.
Oh, 50, sorry, 50. 50 out of 100. Females 50. Okay, so if we work this out, flip and multiply, you get 8 out of 50. Take a 2 out, it'd be 4 out of 25. Decimal answer 0.16, so 16% chance. 16% chance. Now, and you look at that, I think I did everything right there, right? It looks right? I think 2 would be 4 out of 25. Now, a lot of people will get on this problem and says, what's the probability it's a female? If it's a female, they voted yes. A lot of people would say 8 out of 100, right? Put that chart and say 8 of them get out of 100. You know, and that's why you have to be careful when you do these problems. Not it, because it really is 8 out of 50. Because you're given it's a female, so we're only working with this group of people. So it's 8 out of the 50 people.
But like if you reword it so it's like asking, what are the odds the person you choose is female and that they voted?
Then it's,
Then it's 8 out of 100, right?
that's an and question, then that's,
Yeah.
so. We didn't quite get through everything on section 4, 3, but this should get you started at 4. We'll try to finish up 4 on Tuesday and Wednesday. Good? Any questions on that? Good now. Have fun. You have practice over there? You have practice this morning? Oh, you have to be here this morning. Right? Early?
Oh, 5, 6:30. The B squad is so practicing in school.
That doesn't make sense.
Oh, we know. Well, we practice before because of the online classes.
Yeah, the morning practices are good sometimes, cause then you get done after, so I'm like, ah,